So now in this video we're going to look at this circuit again, and what this circuit does, I will turn the power supply on and turn the voltage up. Once I hit about 9 volts, you're going to see that this is the voltage to the power supply rail, and there we go, 9 volts. You see that the red LED starts flashing, and there is the schematic diagram for it. What we're doing is we have the emitter basically on the wrong side of the circuit, but for this circuit it is the right side. So the base is left floating, nothing connected to it. So the emitter is more positive than the collector. It has a low voltage breakdown from emitter to collector, emitter to base, when the emitter is more positive. Whereas the collector has a whole lot higher voltage. It will break down before base to emitter. And so when we put it in backwards, it breaks down easier, starts conducting through the LED, and flashes. Let's zoom in, take a quick look. So I did a few videos where we already looked at this. We're going to run through. I moved the resistor there, 1 kilo ohm resistor, to the positive rail. And in fact, in this video, we are focused on the 1 kilo ohm resistor. I'm learning more about this circuit with each video I make of it. So you can see flat side of the transistor is over there. So emitter on top, base in the middle, collector on the bottom, base is floating, and we have the long lead, the anode of the LED, to the collector. Short lead, the cathode, goes to the negative rail. And now we have the capacitor. So the last few videos I had the resistor going right here. The capacitor was blocking it, and I moved that so that we can see the resistor. And I'm limited on my camera angles and stuff, but there you go. We can only really the gray jumper is blocked right now. So let's go back and get the multimeter. So I'm going to turn the power up to 9 volts so that it starts flashing. Now I wrote 9 volts on here, and 9 volts is the absolute minimum for this setup, and it's not even going to light up if I use a blue LED. So I made this diagram after work a long time ago. I saw it worked with 9 volts with the red LED. That's what I wrote on there. We need 10 volts with the blue LED. So I'm going to get the meter over here, and so we can look at it. So the voltages don't really change that much. You see the flash there. You would think that we have a rapid voltage change. First, let's get the voltage of the rail, and I just have a bunch of different color LEDs from the last video. So it's set to measure voltage, and you can see we have 10 volts at the rail there. And let's go across the capacitor right there. Now there you can see it's holding pretty much steady 10 volts. It's actually a saw wave. We looked at that with the oscillator, or with the oscilloscope, I mean, in the last video. So I'm at both ends of the capacitor basically. I was at the negative rail, the jumper that goes to the negative rail, and you can see that it's there. So that's holding about 9 volts, and almost 10 volts actually. And so this resistor, that has basically 10 volts there and almost 10 volts there. So I bet there's less than 1 volt across the 1 kilo ohm resistor. I have not measured this yet. And so I thought there's going to be more voltage change across the resistor. There you can see, yeah, 0.8, 0.7 volts, in that range. So there's really hardly any current flowing through here. So I didn't realize it was that little current. We can actually measure the current directly. So I removed that resistor. We removed the voltage across the rest of this. Everything now going to the negative rail. Let's set this to measure milliamps. And so it's going to be, I don't even know if it's, yeah, it's going to be changing because we saw the voltage was changing. So that was 0.7. Let's just say 0.7 volts, which means it's a 1 kilo ohm resistor. You divide that by 1,000, you get 0.0007 amps approximately, which is the same as 0.7 milliamps. So we should have 0.7 milliamps of current right there. And yeah, there you can see it's bouncing around between 0.6 and 0.8 in that range. So this is a multimeter. It's not made for rapid voltage changes. but it gives you basically a kind of a middle point, especially if the voltage is changing extremely fast. And so, in any case, yeah, that's hardly any current. So I was more worried about power needs than I needed to be. So it makes sense though. The transistor, now that I measured it, I thought it was conducting fully when I first did this, and then the capacitor was charging. Of course, the capacitor charged pretty quick, and so I should have been aware of that. And I didn't realize the voltage changes were so small. So that's why it's a good idea to learn how to measure these things. And so, again, this is the blue LED. We needed 10 volts to get this to flash. We can do the same thing with the red LED, and I don't expect any surprises here. I expect the exact same thing. But in any case, these are all good ways to learn electronics. So I'm going to turn the voltage down. So it's about 9 volts there approximately. And good, you can see where I'm measuring the rail. Oh, I just measured current, which was very bad. We need to put this to voltage. Hopefully, that is why I always say get the meter off of measuring current as soon as possible. So I probably didn't even put 1 amp of current because I have the meter set. So if I didn't lower the maximum current for the meter, that might have blown a fuse. So that's a good warning. Get off of measuring current as soon as you're done. So there we got 9.14. We measured the voltage across the resistor, and you can see it's holding, looks a little bit lower now, and but it's bouncing around, and so we can measure the current that is letting through at this voltage. So you have to open the circuit, measure current through the meter right there. So milliamps. Luckily this meter, everything, the red probe stays in one spot other than when you're measuring in the amp range right there. So we'll go there to the capacitor, and yep, you can see we have the voltage basically, and but you divide it by 1,000, and so that gives you the current in milliamps. The same voltage across the 1 kilo ohm resistor is the amount of current with the same number, but it's in milliamps. So that's basic Ohm's law. Let's turn up the voltage. That went too high. Oh yeah, that's right, I don't have the circuit connected. So now it's up to 11 volts. We should have higher current, or faster flasher. There you can see higher current right there. So we need that much current fed into the capacitor, and then the transistor turns on briefly to release the voltage, but it doesn't stop at a singular point. The voltage kind of drops a bit and then rises over time and then drops suddenly like that, and then it has to rise over time. So in any case, hopefully that all made sense, and I learned more from this video and reminded myself, get off of milliamps right when you're done measuring. So hope you enjoyed. Thanks for watching. I will see you in the next video.